mentioned about mechanics. If we are dealing with the forces, okay? So we're dealing with the motion of the body and focusing on the causes of the motion of these bodies. So, but then having the dynamics, this is a branch, sub-branch of mechanics that deals with the effects or the effect that forces have on the motion of the objects. Take note that when you do have mechanics, we are talking of dynamics and statics. So for dynamics, we are dealing with the forces that causes the motion of the body, while the statics, from the term itself, so though we have forces involved, these forces actually, uh, uh, the forces that are being applied cause the object to be at rest or stand still. So even if the object is at rest, we can still expect to have forces, but these forces are equal and in opposite direction. That's why bodies are at rest. Okay? So since we'll be having forces, let us identify the different types of forces. But before we do so, let us define first what force is. Okay. So looking at the photos, what can you see on the photos? Wherein we can relate it to forces. Anyone? Kindly unmute yourselves. What can you say about the photos? What
Hello
action?
po.
Yes, Ivo.
Ano po, ma'am? Force po is the push or pull of objects po.
Okay. So looking at the photos, so this, let me have my pointer first. Laser pointer. Okay. So having the first photo on the upper left hand corner. So this one, we have a certain, is this a lady or a man pushing? Okay. So tinutulak niya yung kanyang cart. And then in the second photo on your right, okay, so we have an owner being pulled by her dog. And then, so having the swing, okay. So mga batang naglalaro on the swing, and we have the tug of war, okay. So vertically, ma'am, we have photos that are involving the pull. Okay, so this one is being pulled. So, and the other one, the two remaining photos, we have push. Okay. We define force as simply if you have an action of push or pull. Okay, as simple as that one. If you'll be seeing a motion due to a push or pull, meaning we are exerting a force on that particular body. So, two actions lang yan, push or pull. So, force is a push or pull acting upon an object as a result of its interaction with, take note, with another object. So, for you to say that we have an applied force, first of all, there should be two forces, or rather two bodies that are involved. And between this body, we have either a push or a pull of between two bodies. Okay, for us to say that we have an applied force. And then we have the properties, different properties of forces. Okay, so the first one, a force is an interaction between two objects or an interaction between an object and its environment. So as mentioned a while ago, so there should be two forces to be able to push or to pull objects. Okay. So for example, in this photo, a lady is pulling her hair. Is this a force that is being applied? Do we have force that is being applied in this case, class? Meron ba tayong force applied in this case?
Meron po.
Anong force iyon, Iha? Push or pull?
Pull po.
Pull. Okay? So, pull. Merong action ng pull, but then, how many bodies do we have in this case? Ilang bodies ba merong involved in this case, in this scenario? Class.
Isa lang po.
Isa lang. Therefore, so this one cannot be said to be having a force. Kasi isang body lang. Take note that part of the property of forces is that there should be two objects, at least two objects. Okay? Ma'am, isang body ka lang. Isang body lang yan. Hinihila mo yung buhok mo. Okay? So, therefore, this is not considered as a force. Okay? Kasi, from the property, there should be at least two bodies interacting. Okay? So, hindi mo naman pwedeng sabunutan yung sarili mo. Hindi mo pwedeng hilahin yung sarili ko. Kanyari, sa kamay lang, simple sa kamay, hinihila mo. Pwede mo bang hilahin yung sarili mo, ma'am? Hindi. Right? So, kasi when you're talking about forces, it should be interaction of two bodies. Therefore, this photo does not actually implies the application of force. Okay? So, kung gusto nyong hilahin, ayan, sabunutan nyo yung other bodies. Okay? For us to say that we have an applied force in this case. Okay? Another property of force is that a force requires an agent. What is an agent, ma'am? The one that directly applies the force. Okay? So, yung mismong gumagawa ng force that serves as the agent. So, for example, ito. So, sinasabunutan, hinihila ma'am ng isang babae, isa pang babae. What is the agent of the force? The one that directly applies the force. Ano ang agent in this case? Anyone?
Ma'am, yung naghihila po nung buhok.
And the one that, ma'am, in which part? Which part yung talagang nag-a-apply ng force?
Ano po ma'am, may isa pong other body na nagpo-pull nung hair dun sa isang babae po ma'am.
Okay. When we're talking of agent, the direct part of that particular body, okay, ito ka literal na body, okay, that is applying the force. Ma'am, in this case, ito yung babae, okay. So, in which part? Anong direkta yung nag-a-apply ng force? Yung kamay. Tama ba? Yung kamay mismo, ma'am. So, in this particular case, ma'am, yung hand, yung agent ng force. Okay? So, yung nag-a-apply mismo ng force. That serves as the... In second photo, so we have a player having badminton. Ano ang agent ng force in this case? So, for you to transfer the shuttlecock, tama, naglalaro, ma'am, exchange of shuttlecocks in both corners. What is the agent of the force in this case?
Yung racket.
That's correct. The badminton racket. Okay? So, the badminton racket. Ma'am, siya yung mismo nag-a-apply, okay, ng force. Badminton racket. So, papunta. Pino-push niya. Diba? Push yung motion. Okay? Para lumipat sa kabilang side. Yung shuttlecock. Therefore, the badminton racket serves as the agent of the force in this particular situation. Okay? So, another property of force is that a force is a vector quantity. So, since this one's a vector quantity, force possesses both magnitude and direction. Okay, so again, in representing the force, you draw a straight line and put an arrow that serves as the head, okay, to be able to identify the direction. So you have the tail and the head of this particular vector. Okay. Now, we have 4 natural forces, okay, known in the universe. So let's just mention these 4 forces. So the first one, we have electromagnetic force. Okay, so having the Earth, take note, Earth has its electromagnetic force. That's why we keep on revolving around the sun and rotating around its axis because of the electromagnetic force. So this causes from the electric and magnetic interactions. Okay? And then we also have the strong nuclear force, which is responsible for holding nucleus together in the atom. So take note that at the nucleus, this is where the mass of an object is concentrated. And inside the nucleus, you have the subatomic particles. You have the protons and the neutrons. And then revolving around the atoms, we have, or revolving around the nucleus, we have the electrons. And that force that is existing, okay, inside the nucleus and the electrons are what we call as strong nuclear force. Okay. And then we also have the gravitational force, which serves as the weakest. Ito pa siya yung pinaka-weakest talaga. Weakest force, natural force. So this one acts over the longest distance. Though this one serves as the weakest, but then acts over the longest distance. Okay? And then the last one would be the weak nuclear force, which is responsible for the radioactivity in the atoms. Okay, so when we're talking of, so we'll be talking of radioactivity. This one is, if I'm not mistaken, chapter 3. Okay, so the radioactive components of certain atoms. Okay, so wherein these atoms can simply be found underneath, okay, underneath the core of the Earth. So we have the weak nuclear force. So these are all the 4 natural forces. So let's have the different types. So we know several forces, types of forces, and let us identify some of the common forces. So the first one is the applied force. So when we have the applied force, so this is an applied force is a force that is acted on an object by a person or another object. For example, you're pushing a car, okay? Or you're pulling, for example, a certain nail using the hammer. So any motion which shows a pull or a push, okay, applied to that particular for a particular object. So we have the direct application of the force. We have therefore applied force. Another one is the gravitational force. Okay, so this one is the force of the gravity. So the force of gravity is the force with which the Earth, the Moon, or other massively large object attracts another object towards itself. Okay. So what is the action in this particular case? For the gravitational force, we are being pulled towards the center of the Earth. Okay, patulak, paloob. Okay, we're being pulled towards the Earth. Therefore, there's this action of pulling motion. Therefore, this is considered as a force. To be specific, gravitational force. So by definition, when we're talking of gravitational force, this is simply the weight of the object. Okay? So, in determining the weight of the object, diba, we have mass times the acceleration due to gravity to get the weight. Okay? That's why there's an action in there of gravity, because weight is mass times the acceleration due to gravity. Okay? So, all objects upon Earth experience a force of gravity that is directed towards the center of the Earth. Okay, so having the pull of gravity, again, this is only along y-axis. Okay, so we're being pulled, okay, towards the center of the Earth. So no gravity along x-axis. Hindi tayo pa-side pag hinihila, kundi pababa mismo. Another type of force, we have the normal force. So we denote normal force as capital N. So the normal force is the support force exerted upon an object that is in direct contact with another object that is stable. So if you have contacting forces, okay, contacting surfaces rather. So ma'am, yung dalawang bodies are in contact with one another. So if that would be the case, ma'am, so we have the normal force. And normal force is perpendicular to the contacting surfaces. So this is one body, another body. So we have in contact, the normal force now will be applied perpendicular to the contacting surfaces. Ayan. So for example, we have a certain object placed on top of the table. Okay. So ma'am, since the object is in contact with the table, so we have contacting surfaces. Therefore, the force now will be perpendicular against the weight of the object, perpendicular to the contacting surfaces. So pataas siya. And the weight is going down. Okay. That's the gravitational. Now, another type, we have the frictional force. Okay. So having the frictional force opposes the motion of an object. Okay, so when you're trying to have friction, you are having this force exerted by a surface as an object moves across or makes an effort to move across it. Okay, so the direction of the frictional force is always against the motion of the body. Okay, lagi silang baliktaran. Kung papunta sa kanan yung object, papunta sa kaliwa naman yung frictional force. Okay. And under frictional force, we have static friction and we also have the kinetic friction. So obviously, when you have kinetic friction, so we say that there is a motion on the object. For example, we have this lady in here pushing. So the trolley. Okay. So nasa yung friction, ma'am? Friction in between, ma'am, yung gulong. We have the wheel of the trolley as against the pavement, as against the ground. Okay. So since this one is moving, so ma'am, nagkakaroon ng friction between the contacting surfaces, between the wheel and the ground and the floor. Okay. So we have kinetic friction in here. Same as true, we can also have frictional force applied even if the object is at rest. Okay. So for example, you have this table. We have contacting surface. Having the leg of the table and the floor. Okay? So, since contacting surfaces sila, ma'am, merong friction, and then, since this table is at rest, so we have a static force or static friction to be particular. Okay? So, hindi porket naka-at-rest yung object ay hindi na nakakapag-apply yung force. So it becomes at rest maybe because forces are equal. Forces being applied are equal. So in getting frictional force, simply have friction, whether it's static or kinetic friction, is equal to mu times the n, wherein the mu is the coefficient of friction. So we have corresponding coefficient for static and coefficient for kinetic friction. So you just have to identify the contacting surfaces. For example, we have in here the box, okay, carton is against the floor, which is also made of wood, if I'm not mistaken. Okay, so merong corresponding coefficient of kinetic friction for the contacting surfaces. And then you'll be comparing this one, ma'am, saan ba mataas? Mas malaki ang friction. Okay, so you also have the box, but then, so, ma'am, sa soil directly, sa soil siya. Okay, so obviously, ma'am, mas madaling itulak itong nasa floor sa first photo as against to the second photo. Okay? Especially this one is inclined. And then bato-bato pa. Medyo sandy pa. May mga soil. Okay? So we expect that we have a higher friction in the second photo as compared to the first one. Okay? So mas madaling itulak, mas less ang friction. Another type of force, we have the tensional force. Okay, or simply, we call it as tension. So this one is signified as capital T. The tension force or the tensional force is the force that is transmitted through a string, a rope, a cable, or a wire when it is pulled tight by forces acting from opposite sides. So ma'am, if you have a cable, no, for example, you have a cable. Kuha ko ng tali. Ma'am, why do we call it a force? Anong force meron sa... Ma'am, anong force meron sa kable? Okay. So, if it is simply a rope, kunyari, meron ka lang ID lace. Okay. ID lace lang, wala yung ID mo, kunyari. There's no tension in here. Okay. But when you try to hang, okay, a certain object at the end of the rope, that's the time that you'll be having a tensional force. Okay, because the object is actually having the weight. Okay, so weight which is going down. Okay, so hinihila niya yung rope, yung cable, yung wire. That's why we're having this pull motion, hinihila. Okay? So therefore, you have that tensional force. To be specific, tensional force are those objects so that are being pulled because they are hanging a certain object at the end of this string, rope, or cable. Okay, so pag tension, ang motion is actually pull motion. It's being pulled. Okay. So the tension force or tensional force is directed along the length of the wire and pulls equally on the objects on the opposite ends of the wire. As seen in this example. Okay, so ito naman, kahit na walang nakahang pero hinihila naman, being pulled in opposite sides, so still, you have a tension in there. Pero kung simply, ma'am, tali lang, nilapag mo lang, walang force applied, hindi mo hinila, so there's no tension in that particular case. And then we have the spring force. So for the spring force, since spring can be compressed and stretched, di ba? When you try to stretch the spring, anong motion? Pagka ini-stretch natin yung spring, what particular motion do we have? Pag hinihila. Pag ini-stretch, ma'am, ayan na, hinihila mo. Okay? If you are stretching the object, you are pulling. Okay? And if you are compressing the spring, kinocompress mo yung spring, you are pushing the spring. So, we have a push and a pull at the same time. Therefore, we have force involved. And to be particular, we have the spring force. Okay? So, the spring force, the force exerted by a compressed or stretched spring upon any object that is attached to it. Okay? So, if you hang a certain mass, okay, you are pulling the spring. But you can also push the spring if you want to compress. Okay? If it is simply in its equilibrium condition, ma'am, hindi mo kinompress, hindi mo stretch, kahit spring yan, walang spring force. Okay? Similar to tension. Pag tali lang siya, hindi ka naghang ng object, hindi mo siya hinila, walang tensional force. Hindi. So again, for force to be applied, there should be a push or pull motion. Now, to be specific, in having the spring force, as mentioned in our laboratory, so we do observe Hooke's law. Okay? So for most spring, the magnitude of the force is directly proportional to the amount of the stretch or the compression of the spring. Okay? That's why in our laboratory, we have values for spring constant and compression constant as well. Seeing at the photo in here, ma'am, this one is the equilibrium position of the spring. When you try to attach a certain mass, of course, you'll be expecting that because of the mass, the spring will be stretched. Okay? It will be pulled down by the mass, by the attachment of the mass. So you have a certain displacement x in here. If you double the mass, so you expect also twice the displacement, okay, of the spring. So mathematically, you can simply have the spring force by getting the negative of the spring constant K multiplied by the displacement X. Another type of force, we have the drag force, D. Okay? This is the resistive force of a fluid. So since we're talking of fluid, so when we're talking of fluid, somehow there should be an observation of the movement of the particles, okay, of that particular body. So when we're talking of fluid, we're talking of gases or liquid or gases. Solids ay hindi fluid. Okay? Kasi hindi naman nag-move ang particles ng gases. It is totally compressed. Okay? Now, having the drag force is a general term. Okay, wherein you have a resistive force in either gases or liquids. A good example of drag force is a buoyant force. Okay. So when we're talking about buoyant force, this is the upward force exerted by a fluid on a submerged or floating object. Okay. So since this one, ma'am, for example, you have a bottle container or a bottle, okay, submerged on top, so somehow dun sa body of water. So this one, actually the contacting surfaces, to be particular, the body of water is exerting an upward force, a resistive upward force, para hindi mag-submerge yung bottle. That's why it stays on top of the water. Same is true if you have a ship, for example, okay, traveling, okay, in certain area, place. Okay, ma'am, di siya lumulubog because of the buoyant force that is being applied by this particular fluid, liquid. Okay, sinubmerge mo sa tubig. So this is also, as mentioned, buoyant force is a type of a drag force. Okay. So we have an upward resistive force. Another type of drag force, ito ay gas naman kasi this one is in air. Okay. So we have air resistance or air resistance force. So having the air resistance is a force that acts upon objects as they travel through the air. Any objects, when you try to have it in air, you'll be experiencing air force. For example, ito, nag-skydiving, ma'am. Okay. Nagpo-float sila on air because of the air resistance. Otherwise, tuloy-tuloy babagsak niya. Magkakaroon ng free fall. So when you have the free fall, we are not incorporating the effect of the air resistance. Okay? So the force of air resistance is often observed to oppose the motion of an object. Okay? It is most noticeable for objects that travel at high speed or for objects with large surface area. That's why, to lessen, of course, if you are traveling in air, so nasa airplane ka, so you want to lessen the air resistance. Otherwise, malakas ang turbulence. Right? Especially kapag magpapass through ka sa mga clouds, kunyari. Aside from that, yung mismong air resistance ay
Many years ago,
to minimize the drag force, whether it's buoyant force, of course we want buoyant force. If you want to minimize the air resistance, for example, surfaces are advised to be in a pointed. Mas maganda kung pointed. Patusok. Okay? So, para pag tama ng air, so hindi siya pipigilan. Kasi pag mas, take note, sabi natin, pag mas malaki yung surface area, mas malaki ang effect ng air resistance. Okay? So, wala kang makikita na airplane na flat yung surface. Yung flat yung unahan. Kasi babalik siya. Pag humangin, madadala yung airplane. Ayaw naman natin mangyayari yon, right? Kaya lahat ng airplanes design na pointed yung unahan niya. Okay? Similar to car racing, di ba? So, yung car racers, ang mga ginagamit nilang sasakyan ay yung hood. Mga hood ay somewhat like pointed. Yung bumper nila pointed as well. So, kung mapapansin nyo, yung mga trucks, mostly, di ba, flat yung surface nila. Okay? Yung bumper nila. Kasi hindi naman sila ina-expect to be traveling at high speed. Okay? Kaya okay lang kahit yung front bumper ay hindi pointed. Pero sa mga racing cars, we expect that. So, we are using that one to race. So, therefore, we are expecting to have high speed. Dapat pointed yung bumper nila. And then, we have the thrust. Okay? So, this is a force that jet, airplanes, or rockets propel them forward. Okay? So, ma'am, para maka-gain ng momentum actually, si jet, so, saan nanggagaling kasi? Di ba, when you've seen yung several videos ng jet that is launched in air, so, ma'am, ang bilis niyan. Pag-propel niya, pataas. At this one happens at high speed. Saan nanggagaling? From the gas that is being expelled. Okay? So, kaya makikita nyo ang usok-usok, ma'am, pagka nagla-launch tayo ng kung ano man ng jet sa air. Okay, pwede papunta siya sa ating space center or what. So, ang usok-usok, ma'am, yes. Okay, and tingnan nyo yung fire that it causes. Okay, so kaya doon sa vicinity nito, class, maraming tubig ang kailangan. Okay, para ma-contain yung fire. Kasi this one, again, expels gas, and that gas serves as the agent that pushes the engine of the jet. Okay. So, kung nakita nyo sa news, yung pag-launch natin, yung Diwata, okay, 3, if I'm not mistaken. So, kailan lang yun? Okay. And then, yung nagpunta sa space station, including a billionaire, magkano yung ticket niya sa outer space? $20 million. Okay. Another type of force. Anong oras na ba? Wait lang, class, hindi ko kasi makita. Baka nag-overtime na tayo. Electrical force. So, electrical force. Force due to the interaction between electrically charged particles. Ma'am, in electrical force, where is that push and pull? Okay. In electrical force, we're dealing with the charges, positive and negative. So, if you have similar or like charges, so we say that they are being repelled. Okay, similar charges. So, pagka positive, ma'am, itutulak ka, papalayo. Kasi pareho tayo ng charge. Pareho tayong positive, tulak kita palayo. Pareho tayong negative, magtutulakan tayo palayo. Okay? But then, if we have unlike charges, opposite charges do actually attract one another. Therefore, a certain charge will be pulling the other charge towards itself. So that's the action of the pulling motion. Okay. So in electrical force, we still have both the push and the pull motion. And in getting the electrical force, simply use Coulomb's law, wherein we'll be discussing this one in the latter part of our class. Sa final part. So force is simply equal to the coefficient, Coulomb's coefficient times the charges, Q1, Q2 all over the distance squared. If you have the electrical force, we have also the magnetic force. Okay? So, kung sa electricity, you have the charges, you have positive, negative. In magnets, magnetism is the force that moving charges exert on one another. We have the poles this time. Okay? So, you have the North Pole, you have the South Pole. Same poles repel. Okay, so naglalayo sila. Magnet, same pole na magnet. Ma'am, mararamdaman mo palayo. But opposite poles, ma'am, they attract one another. That's why we have the magnetic force. Okay. And those are the common forces that we have. And all of these forces can be classified according to, so we have classifications of forces. Okay? We have the so-called contact force and non-contact force, or non-field force. So from the term itself, when you have a contact force, we say that the bodies, okay, so the bodies are in contact with one another. Okay, that's why we call it contacting force or contact force. Well, so the non-contact or the field force, so obviously, so they'll not be at direct contact with one another, but due to the field that it experiences, they have this push and pull motion. Okay? So what are the examples, ma'am? Ay, ito pa. Contact force is defined as a force exerted when two physical objects come in direct contact with each other, while the non-contact force is a force that can exert itself even across an empty vacuum of space. Again, the force will just be applied due to the field that is present within the vicinity of the objects. So these are the examples of the contact force. So we have the friction, ma'am. So friction, kailan contact talaga siya kasi wala namang friction kapag kunyari you have your hands. So it should be in contact for us to apply friction. Okay? So hindi ka naman pwedeng friction, ma'am, na pag magkahiwala yung kamay mo. Tama ba? May friction bang ganun? Wala, ma'am. Dapat contact sila. Same as true with the tension. Having the rope, kailangan naka-attach dun yung object dun sa mismong rope para magkaroon ng tensional force. Okay? Kasi kung hindi sila attached to one another, magkahiwalay, walang tensional force dun. Walang force na mararamdaman yung rope. Same as true with the normal force. Okay? With the air resistance force, kailangan nandun ka mismo submerged dun sa air or submerged sa water for the buoyant force. Then you have the applied force and spring force. To mention some of the contact forces for the non-contact forces, so ito ma'am, yung gravity, hindi mo naman kailangan makita na, yung kamay ng Earth, hinihila ako. Okay, towards its center. Wala ka naman makikita na hinihila ka pababa, papunta sa center ng Earth, di ba? Hindi mo nga maramdaman eh. Also, so ma'am, electrical force, hindi mo naman nakikita na si positive ay in contact with the negative. This happens due to the field. Same as true with the magnetic force. Kailangan yan, ma'am, contact, non-contact. Hindi mo naman makikita yung South Pole and North Pole na they are in contact. Okay? It's because of the field. So that's why they are considered as non-contact forces. Okay? And the presentation na pala yan. Questions with the forces. This is just introduction kasi introduction lang to of the dynamics, because in the next material we will be having now the computations, so involving now the laws of motion. So for your assignment, purely concepts lang naman to. For your assignment, since next meeting we'll be having computations already, so ito yung contents natin for chapter 2, so we'll be dealing with this one. What I want you to do is to have solve problems. Okay? Solve problems. Nasaan na ba yung courses natin? Ito. You choose 5 lang. You choose 5 types of forces. Kahit anong types ng forces. Okay? 5 forces you choose. And then I want you to have problems, solve problems. Okay? Look for solve problem. Unsolved, isa-solve nyo. Okay? So you have to include the problem statement and then the full solution. Okay? Of that problem. As preparation for our computation for next week. Next week's discussion.
Ma'am, ask lang po, ilang problem po yung dapat makuha per type ng force na pipiliin po namin?
So for every force, you must have 3 solved problems. So total of 15 solved problems. Okay? So handwritten class. So sulat sa papel. So kompleto ha, yung problem statement, yung full solution. Having degresa. Full solution. And then take a photo, convert it into PDF file. I'll be creating a tab again using MS Form. I'll be creating a tab in the team for you to upload your assignment. Okay? As simple as that one.
Ma'am, kailan po pasahan?
Ang pasahan ay next week. Ang pasahan natin ay, pwede pala bukas, naka-asing kayo. Next week na lang. Kailan na next week natin? Di ma'am, Monday. Monday ng what time? Monday ng 9 AM. 9 AM ang lab nyo, di ba? 9 AM, I mean deadline ng mga laboratory reports. Tama ba?
Opo.
Yes, so papareho natin. 9 AM on Monday. Okay? Other questions? Other questions? Wala ang tanong?
Wala na po ata.
Sige, just be, again, ready with your calculator. Baka magpa-exam na naman ako, ha? Sige, kung wala tayong tanong, I'll just be seeing you on our laboratory class on Wednesday. Okay? So, I am now dismissing this session. Goodbye, class.
Thank you po.
Thank you po.
Thank you po.
Thank you.